All right, we're doing a quick jump ahead from the material that we've been going over to talk about density because we're going to need it for our lab next week. The density of the substance, you may have some familiarity with density if you've jumped into a swimming pool. Sometimes you sink, sometimes you float. And I did the opposite signs for that with my hands. Sometimes you sink, sometimes you float. And that's based on your density relative to the water that you're in. Density is a ratio. Ratio just means divide, basically. It's one thing compared to another. And the two things that we're comparing in this case are mass, like in grams or kilograms. Or if we're on Earth, we can convert from mass to like pounds, a unit that we're probably more familiar with, and volume, like liters or cubic feet, maybe. There's a bunch of possible options for volume. And we get this equation that would be a good one for you to have memorized, D equals m over v, where D is density, m is mass, v is volume. Density is a fundamental property of substances. It's the same for every piece of a substance. So if I have magically pure water that I've got in Norway, I collected water in Norway and I purified it, it's water, and I have water that I took out of the King's River and I purified it and now it's pure water. Those will have the exact same density. They're the same substance. It doesn't matter where they came from. As long as chemically they're the same thing and they're kind of in the same state, they will have the exact same density. You can often identify substances based on their density, and we'll be doing some of that in our class next week. If you change the size of an object, that doesn't change its density. So for example, if I have a small piece of wood, right, it's not going to weigh very much. It's also going to be small. If I take a bigger piece of wood, I've increased the size of the wood, right? So this volume term has increased. But because of making it bigger, I've also made the mass increase more. And since we're dividing those two things, the density, the ratio of the mass to the volume is going to be the same. So it doesn't matter what size of the object you have, a small amount will have the same density as a large amount. We can do density calculations. They're not terribly difficult as long as we remember our D equals m over v formula. So we calculate the density by dividing the mass, m, of a given amount of the substance by its volume, v. So D equals m over v. So in this example, we want to calculate a density for a liquid that has a volume of 22.5 milliliters. Milliliters, right, volume, one of our common volume units. And it also has a mass of 27.2 grams. We want to calculate the density. We've got a formula for that. We just learned it. So to calculate it, D equals the mass, which is 27.2 grams. It's important that we keep that grams with it. And we're going to divide that by the volume of 22.5 milliliters. We can plug that into our calculator. 27.2 divided by 22.5. We get out 1.208, and it looks like that 8 repeats on forever. And our units, the grams, the milliliters, those come through as grams over milliliters, or grams per milliliter. So at this point in the class, this is what we would provide as our answer for the density of this liquid. So relatively dense liquid. Question?
I'm not sure if yours does, but do you round to a certain number?
That's something that we'll be talking about next week. And we're skipping ahead from that. So for now, this is what we would write down. Other questions? Another thing that we can do with density, since it's the same for a substance regardless of the amount that we have, we can use density to identify things. We can compare with known density values, like in this example. So a person purchases a platinum ring that has a mass of 9.67 grams and displaces or moves a volume of 0.452 cubic centimeters of water. Is the ring genuine? The known density, the established density of platinum, is 21.4 grams per cubic centimeter. Any ideas where to start? Yeah, we got to get the grams per cubic centimeter, the density. So we're going to find the density of the ring. Conveniently, we already have been given those values. So 9.67 grams divided by 0.452 cubic centimeters. Plug it into the calculator. We get out a value of 21.39 and some other stuff grams per cubic centimeter. Is that our answer? Got an answer of yes if we round up. So let's say we round that to 21.4 grams per cubic centimeter. Is that our answer?
Yes.
What was the question?
Is the ring genuine?
Is the ring genuine? Does 21.4 grams per cubic centimeter answer the question, is the ring genuine? Is that my TV? $500. Is that my TV? I paid $500 for that TV. Does that answer the question? No, right? So the question that we're answering here is the ring genuine? We calculated the density of the ring. The density matches the density of the platinum. We're trying to answer, is it a platinum ring? If the density matches, there's a very good chance that yes, the ring is genuine. That would be our answer. Questions about either of the two examples? A little bit more. If you have to leave, that's fine. I know we're going a little over time. We can also use density as a conversion factor. So density is mass over volume. We can use it then to convert between the two units that are in it. For example, if we have a liquid with a density of 1.32 grams per cubic centimeter, we can write it this way. And we can convert between grams and cubic centimeters, because those are the two units that are in our value here. So we're going to use some concepts from algebra where we can cancel out our grams and our cubic centimeters basically behave like an x or a y that we would see in an algebra problem. So we are trying to, in this question, deliver a mass of 68.4 grams, and we want to know what? What are we finding? The volume. And we know that we're finding volume. It's right next to our question word. Usually our question word is right next to the thing that we want. So our question word, what volume? So we're looking for a volume. We're given grams. We can go from grams to volume. In this case, probably cubic centimeters. One of the ways that we can do that is starting with 68.4 grams. And the way that I wrote out the units, we've got grams on top, we've got centimeters cubed on the bottom. To cancel a variable out in algebra, we need 1 on the top and 1 on the bottom. We divide them and they turn into a 1 magically. So if we flip this, 1.32 grams per cubic centimeter. I don't know what I'm writing here. Flip. The 1.32 grams goes on the bottom. The cubic centimeters goes to the top. Our grams cancel. The units that's left is cubic centimeters. So we'll get out a value in cubic centimeters. Another way that, a method that a lot of students like to use for these types of density problems is there's this triangle method, and this is the last thing that we'll do. So this D equals M over V. We can also rearrange this equation. If we've got 2 of these things, any 2 of them, we can solve for the third one. And the triangle looks like this. You're welcome to use this if you like. So we've got D and V on the bottom and M up top. It looks kind of like D equals M over V. We've just put the M up in the apex, the top of the triangle. So then any of the things that we're trying to find in this triangle, let's say we're trying to find volume, we look at the relationship of the other 2 things. Mass is over density, so volume is mass over density. If you don't like doing algebra, if you don't like rearranging equations, practice it, work on it. But this will also do the same thing. This is like if you rearranged it. So you're welcome to use this method for rearranging. One last thing, because I forgot. Density. We'll be using this in our lab next week. The way that things arrange themselves. If something's more dense than another, like you throw something like a witch or a duck or a piece of wood into some water, if it floats, is it more dense or less dense than the water? Who knows? Yes, it's less dense. If it's less dense, it floats. So things will arrange themselves, like if we have them in a container, they will arrange themselves so that the highest density things will be on the bottom. Let's say in this example we've got water, and I think alcohol's something like 0.76 grams per milliliter, and we've got some fictional thing that's 1.21. So most dense will arrange itself at the bottom, assuming they don't mix, and least dense will be up at the top. And there are some fun demonstrations that you can do where you layer different colored liquids like this. Question?
Is there also an equation to find mass?
Yeah, so if we wanted to find mass with this triangle, mass is on the top, we'd look at the other 2 things. Density and volume are right next to each other, so those would multiply. So density times volume gives us mass. Any other questions? All right, then that'll do it for density. We'll probably review it again when we get to it next week.